All right. So in this case, we've been given a frequency distribution, and we're being asked a series of questions about this frequency distribution. Now, this one is a grouped frequency distribution or a binned frequency distribution. And so it's not like that frequency is for a specific value as we've seen before, where like that was 12 ones and we had then 16 twos and then 32 fives. No, this is for the group of 0, 1, 2, 3, and 4. We have 12 from that group. And from the group 5, 6, 7, 8, 9, we have 16 from that group. And we call those groups, the name that we're using for those groups is a class. And so when they say what's the lower class limit for each class, well, it's not talking about actually anything to do with the social side of this. It's talking about the bin or the class of 0 to 4. And so the lower class limit will be 0 here, and the upper class limit will be 4 for this first class. And so what we have is we have a series of classes here. And so if we're talking about problem 9, we have a series of classes. So the lower class limit for class 1 will be 0. For class 2 will be 5. For class 3 will be 10. 4, 15, 5, 20, 6, 25, and you get the idea. 7, 30, 8, 35, 9, 40, and 10, 45. And so then the upper class limit will just be 4 for group 1. For group 2, it'll be 9, 14, 19, 24, 29, 34, 39, 44, 49. Okay, and so those are the upper and lower class limits. So that was problem 9, and then that's problem 10. Then it asks, what is the class width? And we got to be a little bit careful here, because it'd be really tempting to just say 4 minus 0 is 4. But if we resort to things like counting on fingers and toes, we can realize that's wrong pretty quickly, because if I do 0, 1, 2, 3, 4, that's 5 values. And so the easier way to see this, the easier way to actually just find it with math rather than counting on fingers and toes, because your class bins could be significantly wider, your class width could be significantly wider than would be easy to count, is you take the 2 consecutive lower limits, any 2 consecutive lower limits, and find the difference between them. And so if I take, so I'm looking at problem 11 here. What's the class width? And if I take 5 minus 0, that'll give me a class width of 5. And we already said by kind of counting on fingers and toes, 0, 1, 2, 3, 4, that's 5. And so I already know that that's correct. But it's easy to see if I just take 5 minus 0, or 15 minus 10, or 10 minus 5. Those are all going to give me the correct class width. Same thing works with the upper limits. It's just usually easier to see with the lower limits. Okay, how many students were involved in this study? So 12 is how many students were involved in this study. And you would think that'd be a hard number to figure out, because we're not told anything about individual students. But we are told how many students were between 0 and 4, and then how many students were between 10 and 14, and all the rest of them. So all we really have to do is sum all of the frequency data, and that will give us the total number of data values, in this case students, that are in this bin frequency distribution. And so I'll have 12 plus, what is that, 3 16s, so 3 times 16 plus 10 plus 11 plus 3 times 3, because there are 3 threes. And I'll get 94 students actually in this distribution. Okay, so 13. It says, how many students had at least 30 social interactions? Well, at least 30 social interactions, I draw the line here because that's where my 30 starts. And at least 30 means everything going in that direction. And so the number of students that have at least 30 will be the sum of those values. And so I'll have 4 plus 3 threes, and I'll have 13. They thought they were clever when they came up with that. Okay, and all right, so 14. They're still being clever, because for question 14, they're asking how many students had at most 14 social interactions. All right, so we'll erase that off of the board that we're working with. And now I want to find how many had at most 14. Well, there's my 14. And it's the upper end of a class. And so I can literally just draw a line right here and say, at most 14, well, it would be everybody below that is what I'm interested in. And so it'll be 16 plus 16 plus 12. And what's that going to be? 44. Okay. Among the classes with the greatest frequency, which class had the least number of social interactions? Well, I look at my frequency table, the frequency side of my table here, and I find that the max is 16. And so I'm really just looking at those 3. And so with those 3, which of those 3 had the fewest social interactions? Well, it's going to be, if I have number of social interactions here, it's going to be the smallest number here of social interactions. And so it's going to be the 5 to 9 group. So 15 is going to be the 5 to 9 class. All right. I hope that helps us out as we work with these binned frequency distributions.